Right. Define binding energy.
So can you repeat?
1 minute, I'm writing on the screen. Define binding energy. Define binding energy. Define binding energy. See, till when you are binded in 12th standard?
What, sir?
Till when you'll be binded in 12th standard? Binded in 12th, till when? Till you write the exam, you're binded?
Yes, sir.
I will say till you get result, in which out of 100 you should get 35 or more, na? Then only you are released from 12th, otherwise you'll be binded back.
Yes, sir.
तो कितने मार्क तक आपको 12th स्टैंडर्ड पकड़ के रखेगा?
35.
35 या उसके नीचे ना?
Yes, sir.
35 मिला तो आई विल से आई विल जस्ट पास ना?
Yes.
और 100 में से 100 मिल गया तो आई विल पास विद फ्लाइंग कलर, आराम से भागूंगा ना, अलग अलग जगह पे घूमने को जाऊंगा. So binding energy means that energy which when given to a body it can remove itself from gravitational influence of earth. The satellite is revolving around earth, मतलब अर्थ के इन्फ्लुएंस में ना, ये मतलब अर्थ ने उसको बाइंड करके रखा है ना ये सैटेलाइट को. अगर किसी ने इसको बाहर
Yes,
से
sir.
एनर्जी दिया सो दैट इट कैन लिबरेट, मतलब निकल गया इधर से, तो मैं बोलूंगा उसका बाइंडिंग एनर्जी रीच हो गया था इसलिए वो निकल गया. वैभव?
Yes, sir.
Basic concept, just remember. Just I'm writing something. If you don't understand, tell me. The minimum energy to be supplied to the satellite. The minimum energy to be supplied to the satellite so that it can liberate itself from gravitational influence of earth is called as binding energy. The minimum energy to be supplied to the satellite so that it can liberate itself from gravitational influence of earth is called as binding energy. So if I know 12th में minimum mark for passing is required 35, but in engineering it is 40, in medicine it is 60, तो मुझे पहला मालूम तो रहना चाहिए ना कितना एनर्जी से पकड़ के रखा है अर्थ ने उसको, उतना मैं बाहर से दूंगा, और मोर देन दैट, देन ओनली इट कैन लिबरेट. Hello?
Yes.
So this followed meaning. if Earth का
Yes.
आजू बाजू में satellite is revolving, it has got energy of 10 joule. So if I give 10 joule from outside, then it can liberate itself or not?
It can.
It can. If I give 12, then
It can.
it can. So minimum is energy what it is having. उससे ज़्यादा दिया तो भी चलेगा. So minimum energy to be supplied to the satellite so that it can liberate itself from gravitational influence is called as binding energy. Definition everybody has followed?
Yes, sir.
Right. Hello, Vaibhav.
Yes, sir.
See, after the lecture, na, you just tell me your other subjects timing. Monday, Tuesday, Wednesday, Thursday till Sunday. तो अगर मुझे जमा तो मैं आपको मॉर्निंग में कर दूंगा.
Okay, sir.
हाँ, खाली क्या ये बैच में ना पूरा हम सीबीएसई पैटर्न से जा रहे हैं, आईसीएसई पैटर्न से जा रहे हैं, तो आपको प्रॉब्लम नहीं होना चाहिए, इसलिए मॉर्निंग में करूंगा. बट यू टेल
Okay,
मी,
sir.
जस्ट गिव मी योर रफ टाइम टेबल. आई विल ट्राई टू मैनेज, डोंट वरी. The minimum energy, please write, all of you write a definition. The minimum energy to be supplied to the satellite so that it can liberate itself from gravitational influence of Earth is called as binding energy. Completed?
Yes, sir.
Next heading, derive expression for binding energy of a satellite orbiting at certain height above Earth's surface. Derive expression for binding energy of satellite orbiting at certain height above Earth's surface. So I will first find what is kinetic energy of satellite, then potential energy, add them to get total energy. Whatever it comes, its opposite is binding energy, because then it will liberate itself. So can I clear this heading first? Hello?
Yes, sir.
एकदम इजी है, डरना मत थोड़ा भी. Consider a satellite of mass m at height h above Earth's surface of mass m, radius r, to be revolving in a circular orbit of radius small r equals to r plus h with critical velocity vc. Again, I'm repeating what I wrote. Consider a satellite of mass m at height h above Earth's surface. Consider a satellite of mass m at height h above Earth's surface. Earth's surface of mass m, radius capital R, to be revolving in a circular orbit. Consider a satellite of mass m at height h above Earth's surface of mass m, radius r, to be revolving in a circular orbit of radius small r equals to r plus h with critical velocity vc. Till this, I think everybody has understood now. It is only diagram I have written. Consider satellite of mass m at height h above Earth's surface whose mass is m, radius r, to be revolving in circular orbit of radius r plus h with critical velocity vc. Everybody is followed till this? Yes?
Yes.
Okay, please write. Akansha, Harshita, Nija, any doubt, beta?
No, sir.
Yeah, please copy. In college, any new chapter started? Or same chapter is going on?
Same chapter, sir.
Fine.
Same chapter.
Done, sir.
Okay. I'm just clearing this. So far we have written specification about satellite whose mass is m, which is at height h from the surface of Earth, whose radius is r, mass is m, revolving in a circular orbit of radius r plus h from center to the center of mass with speed vc. Now, kinetic energy of satellite, comma k dot e equals to half m vc square. A critical velocity for students, those who have attended from beginning, we have derived this formula, that is half m gm upon r. So this is nothing but gmn upon 2r. Kinetic energy, we all know it is half m velocity square. Vc, that velocity I have derived formula, Are you remembering? We have derived VC is root Gm by R. Hello? Hello?
Yes, sir.
We have derived no VC is root of Gm by R. याद है क्या?
Yes, sir. Yes, sir.
हाँ. तो अभी इसका वैल्यू डाल दिया इसमें, रूट एंड स्क्वायर कैंसिल होके Gm by R आया. तो फॉर्मूला इज काइनेटिक एनर्जी का Gmm upon 2R. इक्वेशन 1. कॉपी. Done till this? Hello?
Yes.
So kinetic energy of satellite is Gmm upon 2R. Potential, we know that potential energy of satellite comma P dot E equals to. Anybody remembers what is formula for potential energy of satellite? Just check if you have done in your book, it is written somewhere. Is it Gmm upon R minus Gmm upon R? Just check.
Yes, sir. Yes, sir.
Same na, minus Gmm upon R.
Ye-
So what is total energy? It is sum of kinetic energy and potential energy. So we can say T dot E is Ke plus P. Ke, therefore total energy, I am writing T dot E equals to, this is G mm upon 2R. This is plus of minus GMM upon R. What will be LCM? LCM will be 2R. Hello?
Yes, sir.
So first term is GMM. This will be minus of 2 times GMM. So total energy will be minus GMM upon 2R. Agreed this much?
Yes, sir.
Just copy till last line. We know that potential energy of satellite, then total energy is sum of kinetic potential. Final is minus GMM upon 2R. Please copy to this.
Done, sir.
Total energy minus GMM upon 2R. Thus, when energy of plus GMM upon 2R is supplied to the satellite externally, then it will remove itself from gravitational influence of Earth. Therefore, binding energy is plus GMM upon 2R. So total energy we got, it was minus GMM upon 2R. If I give plus GMM upon 2R, then it will liberate itself because total will become 0. Okay? Hello? Hello?
Yes, sir. Yes.
Clear this much? Wordings clear?
Yes, sir.
Right. Hello? Yes, madam. I have lecture, no problem, no problem. Say. हाँ. Yeah. हाँ. No problem, no problem. What time is feasible for you all on Friday, Saturday? So if I keep Their class is getting over by 4. So if I keep 5 to 5:30, is it convenient? No problem, madam. No problem. I will. Okay, no problem. 5 to 5:30 tomorrow. Yeah, you can send. You can send. You can send on the common group. No problem. I will send the link. Ha. I will. I will, madam. I will. I will send. I will send. Thank you. Thank you.
Done.
Binding energy is plus GMM upon 2R. What we got kinetic energy as?
Sir, GMM upon 2R.
So can I say this binding energy only?
Yes, sir.
What you got potential energy? Minus GMM upon
Minus.
R, na?
Yes, sir.
So if I multiply by 2 and divide by 2, this whole thing is what? Binding energy?
Yes, sir.
So it is minus of twice binding energy. So mostly in
Yes,
MCQ,
sir.
they will give binding energy and they will ask you kinetic. It is same. If they ask potential, it is double of opposite. And total energy is opposite of binding. So write this as more. Done, na? Hello? Hello? Done?
Yes, sir.
Now, if satellite is not revolving at rest at certain height, if satellite is at rest, what will be kinetic energy? Zero, no?
Zero.
Zero. And potential energy will become minus gmm upon r. So total energy will be 0 plus
Minus
potential
GMM.
energy, which will be yes minus gmm upon r. And binding energy will be ulta plus gmm upon. So just remember, if they say satellite is at rest, then 2 will not come in denominator, only r will come. Clear? Around?
Yes, sir.
Alright. ठीक है. Copy करो एक point. This note means in numerical you will be using this or MCQs.
Done, sir.
6 point. If satellite is orbiting close to Earth's surface, then small r, which is r plus h, will be approximately r. Then binding energy is gmm upon 2 into capital R. If satellite is at rest close to Earth's surface, then binding energy will be gmm upon capital R. So if it is orbiting close, then 2 into capital R, but at rest close, then capital R.
Done, sir.
Let's try to define escape velocity. Define escape velocity. What do you mean by escape? Should be there or should not be there?
Should not be there.
Should not be. So indirectly it is liberating. Na? So if this is suppose satellite on Earth surface, if you give velocity and it goes outside the gravitational influence from any side, that means it is not in the gravitational pull of the Earth and it is wandering in the space, then we say
Yes,
that
sir.
velocity is called escape velocity.
Yes, sir.
So the minimum velocity, words are very important. The minimum velocity with which satellite at rest on Earth's surface, the minimum velocity with which satellite at rest on Earth's surface must be projected. देखो डायरेक्शन इंपॉर्टेंट नहीं है, ये बाहर आना इंपॉर्टेंट है, किधर से भी आएगा चलेगा. So minimum velocity with which satellite at rest on Earth's surface must be projected so that it can liberate itself from gravitational influence of Earth. The minimum velocity with which satellite at rest on Earth's surface must be projected so that it can liberate itself from gravitational influence of Earth is called as escape velocity. Right, definition. The minimum velocity with which satellite at rest on Earth's surface must be projected so that it can liberate itself from gravitational influence of Earth. Yes, done.
Yes, sir.
Okay. Derive expression derive expression for escape velocity. Derive expression for escape velocity. So again, same history I am repeating. This is satellite at rest on Earth's surface, whose mass is m, radius r. Consider a satellite of mass m at rest on Earth's surface of mass capital M, comma radius capital R. Let the satellite be projected with velocity v suffix e so that it escapes from gravitational influence of Earth. Just write only this much first. Draw diagram and write this much first paragraph. Considered satellite of mass m at rest on Earth's surface of mass capital M, radius capital R. Let the satellite be projected with velocity ve so that it escapes from gravitational influence of Earth. Can I clear this now? Hello, can I clear this?
Yes, sir.
At escape, kinetic energy of projection must become binding energy of satellite at rest on Earth surface. Binding energy means energy imparted to liberate. This we are giving by throwing it. So it should be kinetic energy of projection. Now binding energy on Earth's surface at rest is gmm by r. Don't write 2r by mistake. And kinetic energy is half m, velocity of escape square. 1m you can cancel. So ve square is 2gm by r. From this we can say ve is root of 2 times gm by r. So this is expression for escape velocity. This is expression for escape velocity. Now copy pull. Vaibhav, please wait after the lecture for 2 minutes. Huh?
Okay, sir.
Harshita and Akansha, today after lecture only I am taking extra half an hour. 5 minutes I will give you break so that we can drink water and relax.
Okay, sir.
Harshita, it is okay for you also?
Yes, sir.
Yes. So that your evening class, if you are having, it doesn't uh, gets clashed with this.
Okay, sir.
Sir, what?
No, no. You all complete only for those who have joined late, not for them. Just complete till last line. This
Oh,
is
okay, sir. Okay.
expression for escape velocity.
Done, sir.
Okay. Everybody has done, then I'm removing.
Yes.
No. Escape velocity we got root of 2 times gm by r. If I separate root 2 and root gm by r, what is this called as? Root of gm by capital R. Small r I replaced capital R. Is it critical velocity?
Critical.
Critical velocity vc for satellite orbiting close to earth, na? Anmol, this is critical velocity for satellite orbiting close to earth. So can I say ve is root 2 times vc? This they can ask you in college MCQ. Escape velocity is dash times vc. It is root 2 times vc. Hello, Amen. Hello, Amen. Amen Dikshit. Complete. Amen.
Yes, sir.
See, I just now split
Done,
this root
sir.
2 as root 2 gm by r. This whole quantity is called critical velocity.
Yes,
But
sir.
it is not small r, it is capital R. So it is critical velocity for satellite orbiting close to Earth. So I said sometimes they can ask in exam, escape velocity is dash times critical velocity. So remember it is root 2 times.
Okay.
If everybody has done first note, tell me so that I can give
Yes, sir.
second
Done.
note. Okay. VE, we got root 2 times VC. So can I say it is 1.414 times VC?
Yes, sir.
Because root 2 value is nothing but 1.414. Correct, na? So this 1.414, I am multiplying by 100 and dividing by 100. So can I write it is 141.4 upon 100 of Vc? Hello? Hello?
Yes, sir, we can.
So it is how much more than 100 in numerator? 41.4.
41.4.
So we can say VE is greater than VC by 41.4%. This also they can ask you in MCQ. Escape velocity is dash percent greater than critical. So VE is greater than VC by 41.4%. Right, second note. If completed second point also tell, so that third also I can
Yes, sir,
continue.
yes.
Okay. Third, VSK is root of 2 GM by R. Now those who have attended from beginning, this GM I can write small g is GM by capital R square. So 2R square G upon R. This is 2. Radius of Earth is 6.4 into 10 raised to 6 and G is 9.8. So this becomes 64 into 10 raised to minus 1 into 10 raised to 6 into 196 into 10 raised to minus 1. So this will become root of 64 into 196 into 10 raised to plus 4. So square root of 64 is 8. Square root of 196 is 14 into 10 raised to 2. So it is 112 into 10 raised to 2 meter per second. Or you can write 112 10 raised to 2 10 raised to minus 3 kilometer per second. So 11.2 kilometer per second is value of escape velocity from surface of Earth.
Done, sir.
Okay. That's all for today in this session. Next week we'll complete